Good evening once again, and I request every one of you to put your attendance in the chat box so that we can quickly start our chapter. Dibyanshu, have you put your attendance? Okay, right. So I think my screen is visible. Please confirm on that bit as also. My screen is visible and my audio is clear for you. Visible, clear. Okay. Thank you for your confirmation, students. So in the last class, if you remember, we have started a gravitation chapter, and you people come up with a question that how to calculate value of capital G, right? There are two G's we have to learn, the small g and the capital G. So the capital G is universal gravitational constant, is it? So how do we calculate that? So as I said in the last class that I would search about it and let you know whether it should be included for our syllabus or not. So when I started researching, I got I found that this topic will be taught to you in 11th standard. Okay, so you are currently in 9th standard, so this you will learn about that in 11th standard. Okay, so don't worry about it, you are going to learn that bit that might be a little difficult for your level, so that's why it is not included in your syllabus, right? So we have already seen what is universal law of gravitation. We have derived a formula that is F is equals to capital G, capital M multiplied with small m divided by d square, where the F is force of attraction between two objects, G is universal gravitation constant, and capital M and small m. These are masses of those two objects, and D is the distance or the separation between them. Right. So this is what we have already learned in the last class, and we have also learned about Isaac Newton and their life and how they how he found the concept of gravity, right? So the SI unit of G can be obtained by substituting the unit of force, distance and mass, that is Newton meter square per kg square, right? So this is the unit of capital G, and its value is, the accepted value of G is 6.673 into 10 raised to the power minus 11 Newton meter square per kg square. Okay, now we will solve a example based on this formula. The mass of Earth is 6 into 10 raised to the power 24 kg, and that of the moon is 7.4 into 10 raised to the power 22 kg. If the distance between the Earth and the Moon is 3.84 into 10 raised to the power 5 kilometers, calculate the force exerted by the Earth on the Moon. And the value of G is given as 6.7, although it's 6.673 something, but it is rounded off to 6.7 into 10 raised to the power minus 11. So what we have to calculate? We have to calculate force exerted by the Earth on the Moon. So we have a ready-made formula, and we have all the values that are necessary. We just have to put, right? So capital M is going to be mass of Earth, that is 6 into 10 raised to the power 24 kg. यहाँ पे 20, यहाँ पे into का symbol होना चाहिए, right? 6 into 10 raised to the power 24 है, but maybe because of some print mistake, or there is some mistake and it has not been printed, right? I hope you understand that. And the mass of Moon is also given here. Capital M is equals to 7.4 into 10 raised to the power 22 kg. तो कैपिटल M की वैल्यू मिल गई, स्मॉल m की वैल्यू हमें मिल गई, d की वैल्यू यहाँ पे हमें दी है. d is the distance between Earth and Moon. So it is 3.84 into 10 raised to the power 5 kilometers, right? So if we make it in the form of meters, we have to multiply that distance by 1000. So it is basically 3.84 into 10 raised to the power 8 meters. अगर हम meters में निकालेंगे, so it would be 3.84 into 10 raised to the power 8 meters. And g जो है वो तो constant है. We know the value of g, that is this. So if we put all the values in the formula here, like here, we can get the force in newtons, that is 2.01 into 10 raised to the power 20 newton. Thus, the force exerted by the earth on the moon is 2.01 into 10 raised to the power 20 newton. Very easy example. ठीक है, अगर इसको सॉल्व भी करना है, so I feel you must be confident about solving these kind of problems. Are you, or do you have any difficulty in solving such problems, like how do we cancel out and how do we do that? No? Okay, great. Okay, so these are the questions for your practice. You can practice it. And importance of universal law of gravitation. The universal law of gravitation successfully explained several phenomena which were believed to be unconnected. The force that binds us to Earth. Okay. Second one is the motion of the moon around the Earth. Third one is the motion of the planets around the sun, and the tides due to the moon and the sun. Next, free fall, concept of free fall. I don't think we have started this, but we are going to start this topic now. Free fall, let us understand the meaning of free fall by performing this activity. So what is the activity? Activities, we have to take a stone, we have to throw it upwards, it reaches a certain height, and then it starts falling down, right? Very simple experiment that is. So when it is going up, so which force is acting on it? When it is going up, I have thrown a stone up, so there might be some force on it, that is why it is traveling or it is going up. So which force is that? The force that I put on the stone. Okay, it reaches a certain height because of that, because of that force, yeah, muscular force, or in simple words I would say the force that I applied on that force. Okay, so it will reach a certain height. The force that I have that the force that I have applied will get cancelled because of the gravitational force at a certain height. When the or the peak height, the force that I applied on that stone will be zero. ठीक है, जहां पे मैंने अप्लाई किया हुआ फोर्स जीरो हुआ, इट विल स्टार्ट कमिंग डाउन. जब तक फोर्स मैंने अप्लाई किया हुआ उस स्टोन पे है, it will keep going up. As soon as the force is cancelled out by the gravitational force, it will it will start coming down. जो स्टोन ऊपर फेंका है ना, तो वो नीचे आने लग जाएगा. So the stone, now the stone is coming towards earth because of the force of gravitation. Okay, there is no any other force on it. So that is what free fall is. We have learned that the earth attracts objects towards it. This is due to the gravitational force. Whenever objects fall towards the earth under this force alone, we say that the objects are in free fall. There is any change in velocity of falling objects. Okay, so did you understand the concept of free fall? मतलब free fall exactly होता क्या है? Do you understand what is free fall? समझ में आया? In simple terms, okay, we are going to learn it in a bit details, but I just wanted to confirm whether you understood or not. What is free fall? Yes. And students, please be responsive in the chat box. Okay, don't sit back and you are like, don't make me feel like I'm talking to a computer. Okay, so you understood that. Let me repeat it again. Whenever object fall towards the earth under gravitational force alone, we say that the object or objects are in free fall. Is there any change in velocity of falling objects? So what would be your answer to this? Is there any change in velocity or no? Is there any change, students? Yes, right? जब वो अपनी पीक हाइट पे रहेगा, द स्टोन दैट आई हैव थ्रोन, जो अपनी पीक हाइट पे रहेगा, देन द फोर्स ऑन इट इज जीरो. ठीक है. एंड व्हेन इट स्टार्ट्स कमिंग डाउन, इट गेट एक्सिलरेटेड, मतलब उसका जो वेलोसिटी है इट गेट्स चेंज्ड. While falling, there's no change in the direction of the motion of the object. Obviously, एक ही direction में वो आएगा. There is no change in the direction. But due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in the magnitude of velocity or any change in the velocity involves acceleration. Whenever an object falls towards the earth, an acceleration is involved. This acceleration is due to gravitational constant, Earth's gravitational constant. Therefore, this acceleration is called the acceleration due to gravitational force of the earth or acceleration due to gravity. It is denoted by g. The unit of g is same as that of acceleration, that is मीटर पर सेकेंड स्क्वायर. ओके, सो जो फ्री फॉल का सॉरी जो जी का यूनिट है दैट इज मीटर पर सेकेंड स्क्वायर. जी इज व्हाट? जी इज एक्सेलरेशन ड्यू टू ग्रेविटी. ठीक है. नाउ आई हैव अ सिंपल क्वेश्चन फॉर यू. इज मून फ्री फॉलिंग? Which or let me simplify the question. Which force is acting on moon? Which force is acting on moon? Earth's gravitational force or the gravitational force simply, right? Any other force? कोई और फोर्स है, उसको कोई थ्रस्टर्स लगाए हुए है, या फिर कोई मून को पुश कर रहा है, या फिर कोई खींच रहा है? एनी अदर फोर्स? नो फोर्स. या सेंट्रिपिटल फोर्स, बट दैट फोर्स इज also because of you know gravitational force itself. Centripetal force is also because of, मतलब जो हम स्ट्रिंग की बात कर रहे हैं, that is nothing but the gravitational force. Gravitational pull की वजह से वो centripetal force basically this is not एक how should I explain this? Centripetal force जो है वो कोई external force नहीं. This is it basically shows the direction of force. मतलब the center seeking force, that is a centripetal force. Okay. Another planets or objects? No. There are no any other planets or objects. Yeah, we can say this gravity of sun may affect moon, but no any object or something like that. Let me tell you, moon is also free falling. Okay, moon is also under free fall. Now your next question would be, what would be your next question? If the moon is under free fall, if the moon is under free fall, so why it is not landing on the earth? Why it is not thrashing on the earth? Right? Right? यही आपका क्वेश्चन होगा, सर मून अगर फ्री फॉल में है तो वो फिर गिर क्यों नहीं रहा है अर्थ पे? How many of you have this question? Let me just check your curiosity. Okay, only 2 students have this question. What about okay, Aryan is also having the question. Okay, let me explain with a diagram. Okay, now see, this is a earth. Okay, let me just take the color of earth so that it will be simple for considering. Just a minute. I'm opening a new page, blank page, so that I can explain you that. Can you see the blank page? Yeah, I guess you can. So let us suppose this is a earth. This is our earth. ठीक है. And I am standing here. ठीक है, यहाँ पे मैं stand कर रहा हूँ. I would be very small compared to earth, but यहाँ पे जो दिख रहा है दिखने के लिए मैंने यहाँ पे थोड़ा सा बड़ा ड्रॉ किया. ठीक है. So if I throw a stone like this, अगर स्टोन में थ्रो करता हूं तो यहां से अगर स्टोन मैंने थ्रो किया तो यहाँ पे गिर जाएगा. राइट. इट विल फॉल एट सम डिस्टेंस. ठीक है. मैंने सीधा ऊपर थ्रो किया तो थोड़ा सा मतलब सीधा मेरे तरफ आएगा. अगर मैं थोड़ा आगे थ्रो किया तो थोड़ा सा आगे वो गिरेगा. राइट. अगर मैं और थोड़ा ज्यादा फोर्स लगाता हूं तो क्या होगा? अगर मैं और ज्यादा थोड़ा फोर्स लगाता हूं तो स्टोन और दूर जाएगा. एग्री विथ मी? यू एग्री विथ मी? या. तो अभी जो स्टोन है वो भी फ्री फॉल में है. जब वो अर्थ पे आ रहा है तो दैट इज अंडर फ्री फॉल. वी हैव लर्न दैट. बराबर ना. नो मैं और थोड़ा ज्यादा फोर्स लगाता हूं. और थोड़ा ज्यादा फोर्स लगाता हूं तो दिस विल लैंड समथिंग सम लाइक समवेयर हियर. ठीक है. मैं और थोड़ा ज्यादा फोर्स लगाता हूं स्टूडेंट्स तो क्या होगा? इट मे लैंड अप लाइक हियर. आर यू गेटिंग माय पॉइंट? ऐसे ही होगा ना. सो मून पे इतना ज्यादा फोर्स है. मून पे इतना ज्यादा पहले से ही फोर्स है. इट इज ट्राइंग टू इतना ज्यादा फोर्स होने की वजह से सी इतना ज्यादा फोर्स है कि इट इज ट्राइंग टू फॉल ऑन द अर्थ बट इट इज अनेबल टू. इट इज ट्रैवलिंग इन दिस पाथ इटसेल्फ. मतलब वो गिरने की कोशिश कर रहा है लेकिन फोर्स इतना ज्यादा है कि उसकी जो ट्रेजेक्टरी है या फिर जो मोशन उसकी जो डायरेक्शन है वो अर्थ मतलब वो अर्थ पे लैंड नहीं होगा बिकॉज ऑफ टू मच ऑफ फोर्स ऑन इट. उसकी जो वेलोसिटी है, ट्रैवलिंग की जो स्पीड है, उसकी वजह से मून डज नॉट फॉल ऑन अर्थ. आई होप यू अंडरस्टैंड दिस. अगर इसमें कुछ थोड़ा सा कंफ्यूजन रहेगा सो आई वुड रेकमेंड यू टू सर्च ऑन द YouTube. What would you search? Why moon does not fall on the earth? अगर आप ये सर्च करोगे so you will get to know. क्लियर? थोड़ा सा मतलब मैंने कुछ जो मैंने बताया आपको थोड़ा सा समझ में आया? आई एम श्योर कि आपको कंप्लीटली समझ तो मे भी नहीं आया होगा. ओके. आप एक्सपीरियंस करो ना. लाइक इमेजिन करो you are standing in wherever you are, like some of you are in Mumbai, some of you are in Bhubaneswar, some of you are in I think Ludhiana, right? Right. So you have too much of power. So let us suppose कोई भी आप एक सुपर हीरो की जो पावर है आप में है and you throw a stone. तो आपने मुंबई से जो but atmospheric pressure, air friction are also present on earth. How free fall is possible on earth. Yeah, that is what we are going to learn. ठीक है. That is what we are going to learn as well. Your question is very very good question. But this is going to this topic will be covered in this chapter itself. Just wait. Okay. We are just into the concept of free fall. Okay, so let's move ahead. Where were we? We know from the second law of motion that force is the product of mass and acceleration. Let the mass of stone in the activity 10.2 be m. जो stone का mass है that is small m. Okay, Divyanshu, you have question? Please type in the chat box till I finish this paragraph. We already know that there is acceleration involved in falling objects due to the gravitational force and is denoted by g. So therefore, the magnitude of gravitational force F will be equal to the product of mass and acceleration due to gravitational force. That is F is equals to mg. ठीक है. तो फोर्स का यहाँ पे हमें फॉर्मूला क्या मिलेगा? F is equals to mg. Now we have a different formula for force as well. that is G, capital G into capital M into small m divided by d square, राइट. सो इन दो फॉर्मूलाज को हम इक्वेट करेंगे, एफ इज इक्वल्स टू एम जी और एफ इज इक्वल्स टू जो अर्लियर हमने फॉर्मूला सीखा वो. सो इससे क्या होगा, दिस m will get cancelled with this m, and we would have small g is equals to capital G into capital M divided by d square. Sir, what if we make a hole on earth and we jump on it? Can we go to the other end of the earth? Well, that's a pretty, that's a very good question. But let me explain you the scenario. Okay, have you seen the watermelon? All of you may have seen the watermelon, right? So consider our watermelon as the earth. Okay, what is highest point on the earth? Mount Everest, right? Mount Everest. And the deepest point will be somewhere in the sea, right? So the distance, or the the distance between lowest point and the highest point of earth, Mariana Trench, I'm not very sure about it, but if you say, let's consider that. Okay, so ये जो distance है highest point और lowest point के बीच का, मैंने आपको अर्लियर वाटरमेलन का एग्जांपल दिया था, राइट? सो वाटरमेलन की जो ग्रीन लेयर होती है, वाटरमेलन में ऊपर ग्रीन लेयर होती है, उसके नीचे थोड़ी सी व्हाइट लेयर होती है, एंड देन देयर इज अ रेड लेयर. ठीक है, 3 लेयर से. सो ये जो डिस्टेंस हुआ माउंट एवरेस्ट और मरियाना ट्रेंच के बीच का, या फिर द लोवेस्ट पॉइंट ऑन द अर्थ का, सो वो सिर्फ वो जो हरी परत है या फिर जो ग्रीन लेयर है, सिर्फ उतना ही है. ठीक है. So is it practically possible to deep a hole? Absolutely not. But since you have asked the question, we will not, land up in we will not go to the other end of the earth, because the gravitational force is toward the center of earth. So even if we make a hole, and if we enter from both end, we'll stuck in the center itself. Will not be, coming out of the other end. Okay. Does that answer? Yeah. Okay. So small g is equals to capital G, capital M divided by r square. अभी r square is क्या, यहाँ पे d square को r कर दिया है. So r is radius of the earth. Let an object be on near of surface of the earth. The distance d in equation will be equal to r, the radius of the earth. Thus for objects on or near the surface of the earth. समझ रहे हो? Now see, r यहाँ पे this is given as radius of earth, but this is basically the distance between earth, center of earth and the object. ठीक है, जब हम स्मॉल जी की वैल्यू निकाल रहे हैं, उस फॉर्मूला में जो r है, r is practically we have to take radius of the earth. हम radius of the earth ही लेंगे, लेकिन that is not actually, we don't have to put a radius of the earth, we have to put the distance between center of the earth and the object. तो मुझे बताओ कि ये d को हम r क्यों कंसीडर कर रहे हैं? Why we are not considering the actual distance and only the radius of the earth? Because for a simple reason, to make our calculations easier. How do we do that? जैसे कि मैंने आपको कहा कि अर्थ की जो रेडियस है, it is very 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 large as compared to what we can reach from Earth's surface. ठीक है, अर्थ के सरफेस से हम अगर प्लेन में भी जाते हैं, प्लेन भी ज्यादा ऊपर नहीं उड़ती है, राइट? सो इट इज वेरी मिनिमल डिस्टेंस एज कंपेयर टू द radius of the earth. So that's why, let us suppose you have radius of, let us suppose this is not the actual length, okay? Let us suppose the radius of Earth is 100,000 kilometers. 1,000 kilometers, okay? And from the surface of the Earth, the plane is flying at a 1 meter distance. 1 meter distance पे नहीं fly होगा, but for example, I'm telling you. ठीक है? So as compared to 1,000 kilometers, 1 meter is nothing, is it? 1 meter is nothing. So we can simply take radius of the Earth. So that's why the D, see, in this formula, you don't have to forget, in this formula, D is always the distance between those two objects. But to calculate G, we take radius of the Earth. Okay. Okay. So why would we do that? We can take G to be more or less constant on or near Earth, but for objects far from Earth, the acceleration due to gravitational force of Earth is given by. Now to calculate the value of G, तो ये जो हम G की वैल्यू कैलकुलेट कर रहे हैं, that is only for the objects near around the Earth. ठीक है, अर्थ के आसपास जो ऑब्जेक्ट्स है उनके लिए ही ये वैल्यू G के एप्लीकेबल है. To calculate the value of G, we should put the value of capital G, capital M, and R. So we all know we know all three values. Capital G की value is 6.7 into 10 raised to the power minus 11 Newton meter square per kilogram square, and capital M is mass of Earth, which is 6 into 10 raised to the power 24 kgs, and the radius of the Earth is R is equals to 6.4 into 10 raised to the power 6 meters. ठीक है, सो ये सब चीजें यहाँ पे हम रखेंगे, एंड बाय कैलकुलेटिंग वी विल गेट 9.8, एंड जो जी की वैल्यू है दैट इज 9.8 मीटर पर सेकेंड स्क्वायर. तो जो स्मॉल जी की वैल्यू है दैट इज ऑल्सो ए कांस्टेंट. Thus, the value of acceleration due to gravity of Earth is G is equals to 9.8 meter per second square. Okay. Now you may have a question. What if अगर हम माउंट एवरेस्ट पे जाके वैल्यू चेक करें जी की, या फिर मरियाना ट्रेंच में जाके वैल्यू चेक करें, सो वुड इट बी सेम स्टूडेंट्स? ग्रेविटेशनल सॉरी एक्सेलरेशन ड्यू टू जी, नहीं, इट वुड नॉट बी सेम. व्हाई? बिकॉज द रेडियस विल चेंज, रेडियस ऑफ अर्थ विल चेंज अ बिट, बहुत ज्यादा नहीं, लेकिन थोड़ा सा चेंज होगा. देयर विल बी नेग्लिजिबल चेंज और वेरी मिनिमल चेंज in the value of G, but it will not be constant. After all, it is a calculation. Right, so which formula do we use for calculating small g? Everybody write the formula in the chat box, and the the meaning of all the constants that we using here. The small g, writing in the chat box. I hope all of you must be writing with me. Small g is equals to capital G into M divided by R square. Okay, if you don't want to write the formula, just write the meaning of all the letters in it. Yeah, G is equals to capital G into capital M divided by R square. What is capital G, students? Gravitational constant, universal gravitational constant. आप कहीं पे पी जाओ, G की वैल्यू चेंज होगी क्या? कैपिटल G की वैल्यू चेंज होगी? Would it change? You go anywhere in the universe, नहीं होगी. What is M? Capital M, mass of the Earth. Not only mass of the Earth. What is R? Radius of the Earth. Okay, and finally the value of G is 9.8. Right? I'm so sorry. Yeah. Let's take the next topic: motion of objects under the influence of gravitational force of the earth. Let us do an activity to understand whether all objects, hollow or solid, big or small, will fall from height at the same rate. जो कि आई थिंक किसी ने क्वेश्चन पूछा था ना कि सर देयर विल बी डिफरेंट फोर्सेस लाइक यू नो the atmospheric pressure and all, so that may be answered here. कैसे देखते हैं. We have to take a sheet of paper and a stone, drop them simultaneously from the first floor of building, observe whether both of them reach the ground simultaneously. We see that paper reaches the ground little later than the stone. This happens because of air resistance. The air offers resistance due to friction to the motion of falling objects. The distance offered by the air of the paper is more than the resistance offered by the stone. If we do an experiment in a glass jar from which air has been taken out, the paper and stone would fall at the same rate. Would you believe that? Now, let me just take to the कि आपने कहा था कि सर there would be pressure, air pressure and the air friction and all that. That's why these forces will be acting on the objects. That is very true. अगर हम अर्थ के एटमॉस्फेयर में है तो there would be forces acting on the object. तो इसके लिए हम एक एक्टिविटी क्या कर रहे हैं? We are taking a piece of paper or a paper page and a stone. So मुझे बताओ, अगर आप लेट अस सपोज आप जाते हो आईफिल टावर पे पेरिस में. Okay, you go to Paris and you climb on the top of Eiffel Tower and you drop a stone and a paper at the same time. Which one will land on the earth first? Stone will land, obviously. Why? Why paper should not? G G जो है या फिर एक्सेलरेशन ड्यू टू ग्रेविटी, वो तो सेम ही है दोनों पे. सेम है कि नहीं है? No, see, mass is irrelevant. Mass is irrelevant as compared to earth. ठीक है. मास इज नॉट द इशू. अर्थ के कंपैरिजन में अर्थ के लिए एक स्टोन क्या और एक पेपर क्या, दोनों सेम ही है, ऑलमोस्ट सेम ही है. आर यू गेटिंग माय पॉइंट? बट द पेपर will not land on the earth because of the air friction and the air resistance and all. Air act on the paper so it can't reach faster. That's the reason. ठीक है. Now we take a chamber in which the air pressure has been removed or there is vacuum. ठीक है. और यहाँ पे if we drop the paper and the stone at the same time, which one would land faster? वैक्यूम में अगर हम करते हैं both will fall in the same time. How is that possible? No air, right? So would you love to see the that experiment? Allow me a second, I will show you the experiment. Okay, can you see the my screen? Yeah, please say it and tell me. See, this is bowling ball, this is a feather, and they have been released at the same time. And see, they are coming at the same space. If you can see here, see, they are coming simultaneously to our earth. Boom. Right? clearly visible, student? Like, or was there any lag in the screen? आप ये एक्सपेरिमेंट देख सकते हो यूट्यूब पे जाके सर्च करना bowling ball and feather experiment in vacuum. Okay, so all of you seen the video? मैंने जो दिखाया वो दिखा सबको? Can you respond in the chat box quickly? Or was there any lag in the video? ठीक है. Okay. We know that an experiment, the object experiences acceleration during free fall. From equation 10.9, this acceleration experienced by an object is independent of its mass. This means that all objects, hollow or solid, big or small, should fall at the same rate. According to a story, Galileo dropped different objects from the top of Leaning Tower of Pisa in Italy to prove the same. As g is the constant near the Earth, all the equations for the uniformly accelerated motion of objects become valid with the acceleration replaced by g. Okay, so we will learn about these equations in the naturally free fall is not happening on the Earth. Yeah, it is happening now. अगर किसी ऑब्जेक्ट पे कोई अदर फोर्स नहीं है, so Earth will attract that object towards it, and naturally it will have the free fall. Right? Okay. Yeah, in vacuum only it is possible. Exactly. Or rather than saying vacuum, we can say if no any other force is applying on the object. ठीक है? So yeah, it's 6:40 already, students. I do have another class, and I think that's it for today. I hope you enjoyed today's class, and I will see you on maybe next Friday or next Wednesday. Okay. So, and we will continue this topic in the next class itself. So yeah, that's it for today. I declare that this class has ended, and you all are free to leave this class. Bye bye. See you in the next class. Bye.